Hello, everyone. Good morning, good afternoon, depending where you are, and welcome to the Scite Summer Bootcamp. We're absolutely thrilled to kick off this journey with you today. As you know, over roughly the next 8 weeks, you'll be diving deep into AI for research, learning practical skills, and earning your AI for research certificate. Today's session, as you can see here on the screen, is AI and Large Language Models 101, and we have two fantastic experts joining us who I'll be introducing in just a moment. Before we dive in, let me quickly walk you through what you can expect from this bootcamp experience. So first and most importantly, your free 2-month subscription to Scite has been activated. If you haven't already, please verify your access on that link, which also my colleague Alejandro will add in the chat here in just a second. So once you go over there, you'll see if you either already have access or if you fill out that form, then you'll get access to Scite until August 31st. And yeah, this is really your playground for the next 2 months to practice everything that we'll be teaching you. Also, quick note, if you just signed up a few minutes ago, it is possible that you're not added yet, and also feel free to reach out in the chat, and then we'll make sure that you're getting added any moment here. As per the session format, each of our sessions follows a similar structure. We'll start with expert instruction, then move into a practical application where you're actually getting to use Scite, and we'll always be wrapping up with live Q&A. So down on Zoom where it says Q&A, feel free to add your questions as they come up, and just know that at the end of the webinar, we'll have time to answer hopefully all, if not most of them. You can also expect to receive weekly emails from us with additional exercises, resources, and some helpful tips to keep building your skills between sessions. Of course, all of that is voluntary. Then something fun, we're running raffles at each live session, 1 winner per session. It's our way of saying thank you for being here live with us this summer. And as you know, regarding your certificate, if you attend at least 3 sessions, you'll earn your official AI for research certificate. On the right-hand side, you can see what that'll look like. This is your real professional development that you can add to your LinkedIn profile, your resume, or really any other place. Okay, so today we're kicking off this bootcamp with session 1. Here you can see the topics over the next 8 weeks. And in each session, we build on the previous one. So you'll go from understanding the basics today to becoming a sophisticated AI-powered researcher by the end of our time together. Okay, let's dive into the price today. So today we're giving away a $50 Ticketmaster voucher to one of the lucky attendees. Which is like the perfect timing for summer entertainment. If you're interested in catching, I believe The Wizard of Oz is on Broadway right now, your favorite sports game, or really any other outdoor activity happening this season. I'll be sending the winner a direct email later today, just like probably an hour or something after the webinar is over. It'll be coming from my email address, which you can see here. And no worries if you don't win today, we'll have one fun raffle every live session this summer. Okay, let's look at the agenda for today. So right after I introduce our speakers, we'll take a journey through the history of AI development, how models are trained. Then we'll be comparing large language models. We'll look at hallucinations, discuss RAGs and what those terms actually mean, and introduce you to Scite Assistant. And then from there, we'll go into the practical application where you get hands-on insight and Scite Assistant. And as I mentioned, we'll open it up to your questions. And remember, this is interactive. We want you to engage, asking questions and trying things out as we go. So yeah, just feel free to reach out if anything comes up. Okay, last thing you'll hear from me, and then I'll hand it over. Let me introduce our speakers today. So my name is Julia Heeson, and as you can already tell, I'll be moderating throughout not only today, but the entire bootcamp. So you can expect to see me quite a lot this summer. And I'm really here to keep us on track, facilitate your questions, and make sure that you get maximum value of each session. So reach out if anything comes up. Then also we have Josh Nicholson, co-founder of Scite and Chief Strategy Officer at Research Solutions, joining us. Josh, want to briefly introduce yourself?
Yeah, hello everyone. Julie kind of covered it in terms of title, but in terms of location, I am located here in Brooklyn, New York. I'm a cell biologist by training, so I'm not an AI expert, so I always feel a bit funny teaching AI. But really, we've started working with machine learning, deep learning, and now generative AI for some time, largely because I think it's not about the tool that you're using, but really about the problem you're trying to solve. And I think AI has been a a great problem solver for analyzing millions of scholarly documents to create Scite. And so I'm looking forward to talking with you guys today and you know, hearing from you as well, besides just the access issues, which seem to be pouring in.
Thank you so much, Josh. And then we also have Chris Vendel, VP of Product Strategy at Research Solutions, join us. Chris, I'll let you introduce yourself and then kick things off today.
Yep, thanks a lot, Julia. Yes, I am focused on product strategy at Research Solutions. I'm originally a geologist, but have been heavily involved in leveraging AI as part of product development for the last 5 to 10 years. At Research Solutions, I'm focused on really understanding what our customers and users need. So what are their use cases? And looking how we can develop new solutions to address those use cases. And today, as we start our journey, we will be focusing on some key use cases that students and researchers at universities, that researchers at companies and government research institutions around the world have when they reach for tools which increasingly involve AI in some way to help them with these use cases. Some of these use cases are around finding information. So whether you need it for your studies or for your research, being able to find the specific content item and the specific information within that content item, whether that's a journal article or a book chapter, is something that many of our users struggle with and hope that the solutions that are now appearing can help with that. Then going deeper, really understanding, what are the significance of these content items? What were the key findings in that journal article? And then extracting information from this information, whether it's data points or insights, which they can then use in a variety of different ways, whether that's doing a literature review or indeed writing a manuscript for submission to a journal article. So these are some of the key use cases that people are trying to find solutions for. But there is a bigger problem behind this. And that's what we're showing here on this plot. So what we are showing from 1900 is the number of journal articles which have been published in millions over this time period per year. And as you see, this has increased a lot over this time period, almost an exponential growth in content, particularly significant in the last couple of decades, driven by increases in research funding, but also major economies like China focusing more and more on supporting R&D and really wanting to drive innovation. So this is the actual problem, the problem of information overload, which makes it necessary to find innovative ways to help people as they pursue these use cases listed here. And for today and the rest of the course, of course, we're focusing on how AI helps to do that. But briefly, a little bit of a history of AI. And what I'm showing you here is interest in AI since 1950. And while this curve looks quite smooth and ever increasing, actually, during this period, there have been times when research into AI has really stalled, interest has decreased, so-called AI winters occurred at various times through this period. But some of the key sort of events which happened since 1950 are shown here. The term artificial intelligence itself originated around in the 1950s. And at that time, Alan Turing proposed a key test to help evaluate whether a machine can exhibit human-like intelligence. Later, around the end of the 70s and the beginning of the 80s, we saw the advent of so-called expert systems. So these were AI programs which were actually hard-coded with rules to help them simulate expert decision-making systems. These were mostly in sort of relatively focused domains within scientific research, with different business use cases, and also in healthcare. Then there was a bit of a lull until around the 2010s, when deep learning and the concept of neural networks appeared. Machine learning itself, the term has been around since the 1950s, but it was really only with the advent of neural networks with many layers became significant and really showed that they could really outperform any of the models until then, especially in image analysis and also in various language tasks. And since then, things, especially the last 10, 15 years, machine learning has then been the real basis of a lot of the advances in AI, which have led to the appearance of large language models, which we are all more and more familiar with in the last couple of years. Also during this time was a very significant event in 2017, which I'll also dive into in the next slides. So what happened in 2017? In 2017, we had the publication of this article here, which was titled "Attention is All You Need." It was published by a group of researchers, primarily from Google. And what they were presenting was a new machine learning algorithm or architecture called a transformer. We will look a little bit more in detail at the actual architecture of this transformer in the next slide. But here I just wanted to focus on the concept of attention, which is in the title of this article. So what is attention? What do they mean by it? So attention helps the model to decide what to focus on. It's like highlighting the most important words when reading and using those as a guide to the next step. Imagine you're reading this sentence. Although it was raining, she went for a run because she loves the rain. To understand why she went for a run, your brain naturally focuses on because she loves the rain. Even though the sentence has many words, your attention zeroes in on the part that matters most for that question. The model does the same thing. It learns to weigh each word in a sentence based on how relevant it is to the current word it's trying to understand or to generate. So attention is how the model decides what parts of the input are most important and when making sense of that sentence or when trying to generate a new sentence in response. So this concept of attention is really important. And in this next slide, we will see how it's put into play within the transformer architecture. In the article from 2017 was this schematic of a transformer architecture. It looks relatively complicated, but we will briefly go over it in high-level terms. So on the left of this schematic is the so-called encoder architecture. This is the part of the architecture which helps to understand the input which is being provided. Whereas on the right side, we have the decoder, which helps to generate then a response to the input to create the output. And both of these tasks are supported by this concept of attention, ensuring that the model focuses on the important words which were provided in the input. In a little bit more detail, so on the left-hand side, on the encoder side, we take a sentence, and first of all, we turn each word into a number that the model can understand. These are called embeddings. Then we add something called positional encoding, so the model knows the order of the words. It's like the difference between the cat chased the mouse versus the mouse chased the cat. After this, the model now tries to understand how each of these words relates to the other using that concept of attention that we just discussed. This highlights the most important words for understanding. This happens across multiple layers or thinking steps. We then switch to the decoder side, to the right side. This is where the model starts generating the response. It could be a translation, a summary, or an answer to a question. But it doesn't just spit out the full sentence. It builds it one word at a time, predicting each word on what it was already generated. While writing, the model again is paying attention, not just to the words it has already written, but also to the input it was originally given. It's like checking your notes as you're writing a summary. Finally, we come to the top of this, on the top right. After passing through these layers, the model chooses the most likely next word, then repeats this process until it finishes the sentence. So if we consider this in very simplified terms, imagine this as like a translator. The encoder is reading and understands a French sentence, while the decoder then writes a good English version, one word at a time, or constantly checking back to see what was originally said in that French sentence. So this was a really sort of transformative or foundational moment in the development of AI technologies and really laid the basis for the large language models that we see today. Because coming forward to November of 2022, we had the introduction of OpenAI's ChatGPT. The GPT part standing for Generative Pre-trained Transformer. So it's using that same transformer architecture we explored just now, but trained on enormous amounts of text from books, websites, and other sources. The model is, as with the transformer, trained to predict the next word in a sentence. But it's doing this in trillions and trillions of times. It can now answer questions, summarize documents, translate languages, write stories and code or emails, and even engage in thoughtful dialogue. One other key difference around ChatGPT is that and what really sort of makes it feel so smart is that it's also fine-tuned using special techniques, including reinforcement learning from human feedback. So it not only completes text, but also follows instructions and adapts to the tone of the context. So that really brings us up to the modern day and what large language models are capable of. And here I'm showing you a schematic of what I just described. So large language models learning from reading billions of sentences. You see here the massive corpora of text data on the left. There's this embedding process, tokenization, where individual words or short words like hello have their own set of numbers. Larger words are broken up into different parts and all assigned their own groups of numbers, which go in to become input to that transformer model, which goes through that process of predicting the next word, comparing it to the input, adjusting through a process called backpropagation, the model, and then repeating this trillions of times until it's getting it right. And that brings us now to where we are with a variety of these large language models now have appeared in the last couple of years since November 2022. Not only has OpenAI continued to innovate and expand what its suite of GPTs can do, but companies such as Anthropic with their Claude model, Mistral, and controversially also DeepSeek, more recently controversial because they were able to achieve similar levels of accuracy, but with a much, much, much lower spend on compute to be able to achieve those results. Because each of these models are trained on somewhat different bodies of content, because they're trained with different parameters or different goals in mind, each of them tend to be good in different ways. Some are great at idea generation, others are much better at analyzing content, others are better for adapting for certain custom applications or for reasoning tasks. And when it comes to solution providers like us and others who are creating AI-supported applications, we tend to draw from these different models depending on what they are good at to be able to, benefit from the best of what each can do. But there are limitations to LLMs. And at this point, I'm going to hand over to Josh to talk about some of these limitations.
Crystal handed over to me with the meme. Yeah, so I mean, as he alluded to in the previous slide and highlighting here, these large language models are basically eating the web, right? There's trillions of sentences there, tons and tons of words. And while they have access to the full open web, they don't have access to every single thing in the world, right? And slowly these companies are trying to broker access, in some cases are arguably taking access. But here we're really, trying to bring this back down to how does this impact you as a researcher? And I think the key thing that, we're trying to point out here is that LLMs are generally not looking at scientific articles, right? And so on the left side, and as maybe you've experienced using ChatGPT or other large language models, general large language models, things can be made up, right? You can ask it a question, it'll very quickly and confidently, with great grammar, give you a response. But it's very hard to trust these things, right? Are these real, actual facts, or is it just like a parroting of something that was on a blog post that was never peer reviewed? Are these real references? These are real researchers. You can see some DOIs, but can I actually click through to that and can I read the text to verify that? And in many cases, there's some big gaps and challenges here, and really some big limitations, I think, to adopting this even more at scale, in varying use cases such as R&D, where it's pretty critical to get things right, right? And so on the left side is a researcher asking about, a bibliography or references, and it's making them up, right? And so this has been, recognized as a problem since day one and continues to be recognized as such. And I don't think it's just really looking at this is a fake reference that it's using, but I think even the output, right? The suggestion, the advice, whatever it is, these need real references. These need real information to be sourced from. And I would say that, scholarly documents, as we'll talk about in a bit, really arguably the closest thing we have to kind of a ground truth, right? There's data, there's evidence, there's statistics, there's peer review. They're not truth, of course. They're meant to be debated, they're meant to be overturned, but they're probably some of the most valuable content in terms of truth that there is.
Right. And what we actually see in the last couple of years is that more and more applications which leverage large language model technology to provide their solutions have been looking to other frameworks such as retrieval augmented generation, or RAG, to help provide that source of ground truth, to help provide that transparency of the information that is being presented and the trust in the facts or the data which is being put there, and being able to cite that information as well. So here we see a basic schematic. A user has made a question to a large language model. It is then drawing on factual sources, trying to find actual real data that it can provide in the response to help provide clarity and transparency and trust in the results that it is showing. Factual sources could be many hundreds and thousands of sources, databases of facts, journal articles, news articles, Wikipedia, and so on. And so by using these RAG frameworks, the response that is then created can cite this information and provide you, the user, with much more trust in the results which are being presented. Here we are showing a query that we made to Perplexity. So what is retrieval augmented generation? And Perplexity, probably many of you have used it or are aware of this. It's a broad-based application that many can use for various queries. And it uses RAG, always has used RAG quite extensively. In this case, what you can see where it is getting the information from for this particular response. And you'll see that it's drawing on various companies' blogs, including NVIDIA and Amazon, but also Wikipedia as well. What this particular response does not show is any scientific or scholarly journal content as being the source for any of this information. And that's what these other applications that we list here on the right, how they are particularly different to many of the large language model applications, and also to Perplexity at the moment, because they are really focused on providing a basis for the responses that they show from the scholarly literature, providing links and citations to that content. So Elicit, Consensus, Scopus AI, and of course, Scite.ai as well. But there is a difference. And Josh, what is that difference for Scite amongst all these applications?
Yeah, the difference is that, it's not easy to just plug into one place and get access to every single full text article in the world. And so we have spent years partnering with publishers, in a copyright compliant way to sign indexing agreements that allow us to utilize the full text to create smart citations, right? This is the ability to analyze the full text, extract out information, and to do it at scale using AI, right? And so again, we've been using AI, and I mean this in a broad term, since day one, largely because we've been dealing with millions and millions of documents. And so we've signed, a couple dozen or about 40 different indexing agreements to date. And here it's not an exhaustive list, but you can see kind of the ingestion of these smart citations over time from the full text from a variety of different sources and leading publishers. And so it's not just a focus on biomedical or just on social sciences, but really looking across disciplines to make sure we have a comprehensive coverage, right? And I think that's really important for grounding LLMs in the literature and being able to use these very powerful new technologies in a way that's trustworthy and in a way that's useful for us as researchers and students.
All right, and that's a really key differentiator when we compare to all the other tools which are out there. Here we are showing quite some detail, although this has also been distilled from a lot of detail, which the library at the Hong Kong University of Science and Technology has provided. A few years ago, they already did a review of many of the tools which were around at the time, looking at the various functionality, source data, strengths and limitations. But just recently in June 2025, or just over a month ago, they provided an update, and that is the information we are showing here. Yeah, and so Josh, what are some of the things that stand out in this comparison?
I think the first thing that stands out is that there's a whole plethora of tools now, right? Each day I see a new tweet thread or X thread, highlighting a new tool for this, a new tool for that. They're taking various approaches. They have different UI, UX. Some are using deep reasoning models. Some are using this LLM versus that LLM. But primarily, most of them are plugging into a single source, which is Semantic Scholar. Semantic Scholar is primarily open access, or all open access, I should say, as well as metadata. It's free. It's a great resource. It's easy to go ahead and get a lot of full text scholarly documents, as well as titles and abstracts, but not everything, right? And so again, a key differentiator here is what can the LLM, what can you, call to ground this response. And so at the top, again, we've done all this legwork signing these different indexing agreements to make sure we have a comprehensive coverage. That in turn means, better generative output, right? Are you getting something from the methods section? Okay, yes, that's great if you have the methods section, but of course, that's necessary to have this. And so I think, as you evaluate these tools, there's a variety of different use cases. The general, LLMs like or chatbots like Perplexity are great, right? They're very powerful, they're very flexible. But I would argue for different vertical workflows, such as scientific research or research in general, you're going to start to choose different tools for different use cases, right? And you see this in law, where again, they're more focused on legal text and as well have differentiators. And here, we're focused on research and of course needing to have access there. And so this will be shared afterwards, but I think the key thing that we're calling out is the underlying source data and really the comprehensive coverage that Scite has.
All right, and here we then, put that in context of Scite, we have asked Scite that same question that we put to Perplexity: what is retrieval augmented generation? And here, of course, you see a fairly typical responses you would expect from a large language model, but that key difference there with scientific articles or scholarly articles being cited. And in the first sentence here, or the first paragraph here, notably, it was able to reference kind of the key article when it came to sort of the advent of retrieval augmented generation was this article from Lewis et al. In 2020. Josh, anything you'd like to talk about here before?
I think also key here is that, we started Scite, and as the name suggests, to really kind of create the next generation of citations, right? So it's enough to show an article, but is that article right? Has that article been challenged? Has it been supported? How has it been discussed more broadly in the literature? And so, yes, I think it's very valuable that we're showing the context and you can see that information and quickly validate, here's this insight, here's this data point, etc. here is this article. But then we go a second layer deeper, and you can see not only here's the article, but how has it been cited, right? It's received over 1,400 citations, 2 supporting citations, right? And so you can click through and see more generally, how has the literature discussed this article? Is there a debate happening around it? Is there a difference in findings? Or is it a highly supported article? Not just is it highly cited, and not just does it exist as a real article. And so I think that's a pretty critical aspect, which I'll share a little bit more about now.
Yep.
Yeah, and so, if you've been on a webinar with me, you've probably seen some version of this, but I think this is important, right? It's not enough to just serve up an article and say, this is the article, that's the truth, this is the fact, etc., right? Around 2012, towards the end of my PhD, a lot of concerns around reproducibility emerged. They continue to be discussed and debated and highlighted. Is how do we trust this article, right? Is that something we want to rely upon? And that has big societal implications, whether that's vaccine policies, whether that's city planning, whether that's drug development that can cost, billions of dollars and take, decades of work or a single decade of work. And so what does the world look like, without Scite? And why did we create Scite? And so this is actually one of the main articles coming from my PhD. Naturally, you look at where is it published, who are the authors, what are the affiliations, and then for a long time, and even today, you look at metrics, right? How many times have been viewed, how many times have been cited, how many times have been downloaded on certain publisher pages, how many times have been shared on social media, right? Has it been shared in a lot of reference managers? Has it been shared on Twitter? Things like this. And so we use these as heuristics because, as Chris highlighted in one of the earlier slides, there is a massive amount of information. We can't read every single article mentioning chromosome segregation. You'd never be able to do any experiments. You'd never be able to, leave the computer. And so this is necessary, but I think, there's ways of improving them, right? Journal brand does have some value, I would say, but there could be wildly wrong things in, prestigious journals and vice versa. There could be some very right things in journals that are even maybe considered predatory. And so our focus, has been on the number of citations, right? And so if you click through to the number of citations, you can see a list, and this is generally what we've expected of citations, right? Here's all the articles that cite it. And this is what this has looked like for decades, right? Whether you're looking at the gold standards of Web of Science or Scopus, these are how citation indices existed. I would say students, especially undergraduate students, are not really engaging with citation indices. Maybe you engage with them when you're doing tenure and promotion packets. Maybe if you're looking at ranking, maybe if you're doing bibliometrics, these are very valuable. But because they're a bit abstract, they're a bit high level, they're not really a place for like search and discovery, right? You're going to PubMed, you're not necessarily going to Scopus here to find, an individual article. And I think that reflects the fact that there's only so much use in looking at 66 different documents, right? What do they say about this? I can't open all 66 different documents. It's way too much work. It's probably costly, or it's especially costly now that I'm outside of university. And so we kind of use these citations as a superficial number. A high number is good, a low number is not so good. That's it, right? Let's make sure that we can publish things that get highly cited, that highly cited equals good. And what we're trying to move beyond is that, there's a lot more context and nuance behind just these numbers, right? And so here is that view through Scite. You can see, yes, there's a number of documents that cite it. It is the list of titles. But then what we do is we go into the full text of the scholarly document, hence our publisher partnerships, and a way to do this in partnership with publishers to extract out and display the full text of scholarly documents, right? And so this first citation statement, you can see we've extracted that from the results section of the full text of the article, and then we're classifying that as presenting supporting evidence based on the text. And we're using a deep learning model to do this, right? We're looking at that text. It says in agreement with previous work, cites my article, and then it says the trisomic clone showed similar aberrations, albeit to a lesser extent, and then highlights where the figure is, where the data is, where you can verify that. And so this used to be magic to me because we were analyzing all these sentences and you say, wow, how does a computer know this, right? It almost seems kind of standard in today's world with, the very powerful LLMs, etc. But this underpins and is really, critical and important, I would say, for building out these next generation research and discovery tools. And if you click one more time, I think you should actually see this broadened a bit more. Just to highlight again, that, it's not just a bunch of titles, not just a flat list, but it's really showing the context. It's also much more than just, is it supporting or contrasting? Because I think even if there was no deep learning classification, showing how something has been cited, where has it been cited, is very valuable, because it's like getting, all these experts that have spent years, probably a lot of money doing the research, getting their opinions, getting their feedback, getting their evidence, getting their analysis to help you better understand content. And that's important for the human. And as we're going to show, that's also important for LLMs.
All right. That was a bit of an introduction to Scite.ai, and we've looked at, the history of AI and some of the key terms and concepts which really underpin how AI is evolving at the moment. We got 2 more slides before we head into the practical part. Again, we're drawing here on information and reviews and analysis from the Hong Kong University of Science and Technology. We've distilled that a little bit with AI. And what we're really doing here is returning to some of those use cases that I highlighted at the top of the session, and looking how and understanding how Scite, addresses these use cases, also in comparison to some of the other solutions which are out there. So one thing which comes very clear through the analysis is that Scite Assistant remains very highly ranked compared to others, not only, leveraging large language models to provide the type of search experience that you would expect from an AI, but providing that critical citation context so that it becomes very useful for understanding the consensus or the controversies in the field, as Josh was describing. When it comes to analysis and summarization, so being able to dig through content, find the information that you want and pull it out in useful ways. When we talked to a lot of our users last year, one other name kept on popping up a lot, illicit. And it kept on popping up a lot, especially for one very specific thing, which was the ability to extract information, not just as a paragraph or as in sort of essay format, but in a table format. So being able to assign, choose what you want to appear in each column of the table, and then be able to extract information that way. It just makes it so much easier then to take that information and incorporate it into other use cases or things that you want to do. And so, yeah, we're happy that we're able to also provide this ability since the beginning of the year, which really brings us on par, in terms of that type of UI. When it comes to content creation, for instance, manuscript writing, that's not, has not really been the focus of Scite Assistant until now. There are a lot of writing tools out there. ChatGPT itself is amazing at helping you format and create text and change formats as you need. But of course, Scite Assistant provides that citation context, those verifiable information and facts, which you can trace back to the original content, which can then be easily included in the writing from those potentially from those other tools. And we get a lot of great feedback, and we're very happy that we're able to provide or continue to work very closely with our customers, such as Joshua from the Vanderbilt University. Really, as I said at the top of the session, understanding their needs and helping to evolve the tool in line with that, and as also technology is evolving. And on that last point of how technology is evolving, the last slide is focused then on, where AI is going at the moment and what we may expect in the next year or two. This, last year, if someone asked me about the future of AI, I would have said the future is agentic. Now, that future has definitely arrived. There are many agentic AI tools, so kind of semi or fully autonomous tools able to, take, a goal or objective, reason it through, and actually take action on it as well. For instance, planning and even booking a holiday. Also related to that is the deep research applications, which you may have used, ChatGPT or Perplexity. So, tools which can really, help guide you through a research project, spends a lot of time thinking about it and making sure it finds the right information and being able to provide you with really excellent and deep and insightful reports. And of course, many of the tools we now see are making much, much better use of RAG, connecting to trusted sources of information to make the results that they provide much more verifiable. In the future, we'll be seeing, a lot more so-called multi-agent systems. And it's really about AI becoming much more embedded in complete workflows from end to end, whether that's as a student or a researcher in a university or in a pharma company. AI tools will become much more end-to-end sort of trusted co-workers across the whole workflows. They're becoming much more trusted in various other ways as well, including privacy and cybersecurity. And of course, that critical part, auditability, being able to verify the results and trace back where the information is coming from. And finally, we've already seen the rise of other more domain-specific foundational models, for instance, large language models, which are focused on chemical information or physics information. Before we move on, Josh, any final comments on where AI is taking us?
I mean, I think the one comment is that it's very hard to predict that, right? So, new things emerge with new ways of accessing content. There's a lot of, stuff looking at model context protocols, which is, really a framework for LLMs to interact with a variety of different content. And so I think we're going to continue to see very quick advances, a lot of surprises. And it's good to evaluate everything, pretty critically, from the tool you're using to the approach to like the data. And so yeah, I think it'll be interesting to see if we do this again next summer, where we are in terms of things, just because of how rapidly things are moving.
Cool. And with that, we will now wrap up this part of the session and move on to the practical application.
Yes, my favorite part. Thank you so much, Chris and Josh, for this amazing overview. And I see we have a few questions already. So after the practical application, just to remind you, we'll have time for questions. Okay, so I hope by now all or most of you are able to access Scite. I think we figured quite a lot of that out as well. So I'll send a link here to access Scite Assistant quickly. So the idea right now is if you open Scite Assistant, search for any topic of interest to you. It can be a research question, concept, methodology, anything that comes to mind, just to start getting to know Scite Assistant. And as you explore and take a look at the results there, take a look at the sources. Are they credible? Are they directly related to what you're actually trying to find out? Take a look at that contrasting. If you have any supporting citations, as Josh just explained to you. Does Scite provide comprehensive background and nuanced understanding to your question? And also, as I mentioned, are there any research gaps or controversies that are being pointed out as you take a look at Scite? And while you do that, I'll pull up a poll here in just a second. And we'd love to know, based on what you're experiencing in Scite right now, just share your feedback with us and with everyone, and then we'll be able to share this. Anything, Josh, Chris, you want to add to this practical application here?
No, I think this is just, really kind of getting your toes wet, if you will, and starting to explore this. And, as we'll show right after this, there's a lot more that you can do than just a simple prompt, right? It is very easy to put in like a plain language query or prompt, and you'll get a good response, hopefully, as we see here with boats. But it's not always perfect, right? And as we walk through, in the next session, there's a lot of different things you can do to really improve that. And I think, as you understand how tools work, as you understand the infrastructure that Chris went over, that's really important to understanding the limitations, because while they feel like magic, and they are in many cases, they're not, right? And so there's ways of utilizing these tools that can make them more effective, that can save you time while limiting, risk and, other challenges that you might face if you just kind of blindly expect everything and anything from them.
Yeah, thank you so much for adding that. So see quite a lot of answers coming in here. That's great. Also, if there's anything you see, you can also feel free to add it in the chat here. Maybe something you're noticing, something that stands out to you. Okay, looking forward to using it. Okay, not used yet. Okay, that's fine. Of course, we have 2 months to do this, so this is also great. In your free time, feel free to open it, use it really for any use case, play around with it. That's always the best way to get to know it. And as Josh mentioned, the next session, today in 2 weeks' time, same time, we'll have advanced prompting techniques. So we'll actually show you how it can build your prompting search strategy, all the advanced filters, settings to make sure that the response makes sense to what you're looking for specifically, right? Okay, so I see some questions that I think we can answer before we officially dive into a live Q&A. Josh, is there a list of publishers with whom agreements have been reached? List of journals?
There is a list of publishers. Journals will quickly get into the thousands. We do also have a page where you can look at every single journal and look at citation metrics for that. And I think that's cite.ai/journals. And you can look at the dashboards. In short, we have references from all full text articles. So we're at the baseline of a traditional citation index. We then have almost all abstracts from every single publisher except for Elsevier. And then we've signed about 40 different indexing agreements with major publishers. And we can share that list. We just announced actually American Society of Microbiology as a new partner on that list, I think last week or the week before, and are continually, doing that. Good question.
Awesome, thank you. This webinar is being recorded. I just saw a couple of questions come in there, and you'll be receiving the recording, of course, and the entire bootcamp will be made available on demand. So if you want to rewatch anything specifically, yeah, we've got you covered. And if you just signed up, I just saw that question, feel free to reach out to customer support team. They'll be able to give you access, yeah, as soon as possible. Okay, I think you've gotten to use Scite Assistant. We see quite a lot of responses in the poll. This is awesome. We'll also be sharing the first word that you just shared when that came to mind when using Scite Assistant. So we'll be sharing like a word cloud later, so you can actually take a look at that in an easier to digest way than me showing you a couple hundred responses here right now. Okay, Josh, how about you show us a little bit of Scite Assistant site and like a use case so people can see it before we actually dive very deep into it next session.
Yeah, so I'm gonna share my screen. You can stop sharing. Okay, so here is essentially a prompt that I have used previously. And so here it's just simple, right? It's a question. What is the mode of action for anti-seizure medications? You can see it gives references. But what I want to point out here and what we're going to get into in the next session is why is it choosing this one from 1987? Why is it choosing this one from 1995? Right? How can I control these things? Are these systematic reviews? Are these clinical trials? Are these coming from abstracts? Are these relevant articles? And what we're going to highlight in the next one is really that there's a lot of control under settings where you can specify all these things such as the year, the publication types, the response lengths, individual journals, dashboards that are created from systematic searches, which we'll show in the next case. You can select models, etc. And so while you can simply do a plain language prompt, there's a lot more that you can do as a user to really kind of control, what is a response that is useful to you, right? Because we all have different use cases. Maybe you want to summarize articles to make a rap about, science. Maybe you want to, go through 1,000 articles to look at the sample size. And so that really comes into, I think, some training and some practical use cases looking at a site. We'll also talk through how it's not just about paragraph output, but you can get, tables where you can really ask and utilize AI in a pretty powerful way to look at, again, sample size and things like that. And so I'm not going to dive in too deep on this because that will be the focus of the next session, really, practically using this and what are some strategies to more effectively use it. Because I don't think we want to promise here that Scite's perfect, right? No tool is perfect. And how we think of designing the tool, displaying things, is for you to be able to quickly check things, for you to be able to verify things, and for you to be able to build trust in a way that you can see and start to utilize things. And so that's all I want to show, in this stage. But yeah, much more and much deeper on the next session.
Amazing. Thank you so much, Josh, for that overview of Scite here. Okay, Q&A. Awesome. Let's see. Let's pack as many questions as we get into the remainder of the time here today. So the first one is, does Scite has its own custom model, or does it use a closed source model?
I'm sorry. Can you repeat that, or Chris, can you take that?
Yeah, so we leverage variety of OpenAI models, the various ChatGPT models, but also from Claude, from Anthropic. What is critical, I saw a few other questions here about, does information go back to training the LLM? In general, no. So yeah, there's no concerns there.
Awesome. What do you think of Liner AI for scholarly research?
I don't have a specific comment on that. I mean, I think, again, there's a variety of different tools. We showed some of those. I'm not even actually super familiar with linear AI and like how this looks, but I think we're all kind of coming together to try to approach how can we help people do better research, right? And I think there's some use cases where the UI is better and like we want to follow that or look to that, as an inspiration at Scite. In other cases, there's things that we'll never do, right? Looking at research adjacent things and things like that, or maybe we'll partner with these different groups to make sure, the best of both worlds can kind of come together through integrations and partnerships. And we do that with some of the tools, in the space. The biggest thing that I can say, though, is not many people, really no one, has gone out to go do, this legwork of signing dozens and dozens of indexing agreements. Some groups have, but they have that content pre-AI world, right? So citation indices have existed for decades. They have all the full text in the world. They don't have the rights to be able to analyze content at scale and to utilize it for many applications. And so I think, Scite got pretty lucky with the timing, as well as the technology, being able to analyze research articles using machine learning, deep learning, and AI in general at scale.
Awesome. Thank you. Is Nature Publishing Group included in Smart Citations?
Open access will. We do not have every single full text article from Springer Nature, but increasingly there's more and more OA content being published, especially from Springer Nature, which I think is the number one or two, number one open access publisher in the world. And so I don't want to simply say no, because we probably have millions of full text articles being included from Springer Nature.
Great. Here's a use case. I'm a librarian who works with social sciences, especially education, counseling, and human development. Often these models are so heavily STEM, they fall off the cliff with social sciences research. Just wondering how you believe Scite stacks up to other social science research.
Yeah, I think that's a really important point. And so I am, a cell biologist, so oftentimes I'll show chromosome segregation. I'll show these biomedical examples. Biomedical, research also receives so much funding, right? There's $40 billion a year dispersed from the NIH. There's a lot of publications, right? And so a lot of our publishing partners are completely biomedical publishers. With that said, my co-founder is a social scientist, psychologist. He's going to be giving one of these lectures. I'm not sure of the date, but Julia might know, that talks about that use case. And so, we value all of research, not just cancer research, but research that influences city planning, that influences, how children are learning English as a second language from watching Peppa Pig, all these different things. And that's truly why I think, research is so beautiful, is that it doesn't just impact like, hey, I'm looking at this protein, I want to make a drug, but it impacts literally kind of everything you could think of. And it's pretty remarkable to find there's papers on almost any topic, some things that, are not even appropriate for this talk, but you can maybe know what I'm referencing if you've been on Skullcom Twitter recently, where there's a scientific paper going around.
Amazing. Thank you so much, Josh. And that session is August 19th. And I just added a link in the chat here, which has kind of like the session overview, all the dates, what we'll be covering. And then if you added the sessions to your calendar with that link that I sent, then you should be all set there as well.
The one thing I will say is we do have direct relationships with publishers that are social science publishers only, right? Cambridge University Press, Wiley has a lot, American Psychological Association, Sage, et cetera. And so it's a big focus for us. And I do think, in some cases, there's some challenges for us. Humanities is one, right? Humanities, the content do not have digital object identifiers in many cases, these manuscripts. And so certain times that's a technical limitation where like our architecture has been designed around looking at DOIs. And if it doesn't have a DOI right now, it's a little bit hard to see it. But certainly it's on our goal to include all of that. And even, included in our database is some non-English content as well, because I think the diversity of ideas and disciplines extends beyond just biomedical versus social science, but also geography, right? Are we including content that is in non-English, maybe from the rural South, et cetera? And we're pretty proud of some of our indexing partnerships that are with Cielo or that utilize content from Latin America, and really a variety of different languages. Almost kind of any language you could think of, has been indexed in Scite.
Amazing. How do you handle or mitigate hallucinations? What techniques do you employ? Great question.
Yeah, so again, I'm going to advertise for a later session where I think we really get into the kind of the technical details of this. But we are, a couple things from the UI perspective. So we're running, RAG, this process that Chris describes on, our smart citations. And so we're doing some semantic similarity. Is that matching? So is there some verification of what is the output saying versus that? And then from a UI UX perspective, we're showing you that content so you can see it. It is generating based on that content. And then, beyond that, as I mentioned, we show how that article has been cited as well. And so we think about that from the AI perspective, which I'm probably the least, at least capable person of talking about that. Dom will talk about that, I believe, in various detail, maybe almost too much detail. And then, from the technical perspective, the UI perspective, and then the citation perspective. So all those things, including training, I think are important because you can get hallucinations, right? If you really want to break a tool, you can do that. But, through training, through the UI, and through automated ways, you can really limit it and, start to use the tool pretty responsibly.
Amazing. Another great question for the table feature. While you have the option to add a new column based on your own description, will you provide out-of-the-box options like findings, methodology, research gaps, and others?
It sounds like you're on our staging server. So yes, that's coming very soon. Just saw a screenshot of that. I think it just needs to be cleaned up a little bit. And I think that is to really kind of help you understand what you can put in. We've already added some pretty unique features to tables that allow you to say, hey, I don't want a full like 2 or 3 sentences in this. I just want the number, or I just want yes or no, or I want bullet points. And so there's a variety of different flexibility. There's almost so much flexibility that it gets to be a little bit overwhelming, where it's like, okay, you can choose 4 different models, you can choose 4 different ways it responds, but that's because there's so many different use cases here and so many different users. And so defined or pre-populated prompts for tables is very close. I think it's just passing internal testing. And then we've done a lot of work on allowing you to say, I don't want it to like give this verbose answer. I want a yes or no, or I just want a number so I can sort through these things in columns.
Amazing. Okay, so we'll be able to answer like maybe 2 or 3 more questions. Are full journal articles available or just a citation abstract?
So we do integrate with a variety of different services. We also just mentioned this yesterday that you can get access via Git FTR, a publisher, service that allows you to utilize your entitlements from your university or for your company to get access. We also utilize integration with LibKey, which again is utilizing that, as well as OA. And so you should see as a user view PDF. And we do that in a way that's pretty intelligent, depending upon who you are as a user, with the main goal of trying to get you access in a copyright compliant way to the version of record as quick as possible, right? And so one click, here's the PDF, here's a document. And so we've done a lot of work on that recently as well, to help you, not just get an insight from it, but to actually get that real article and to read the full text of that, which I think is important, right? We're not trying to say everything's captured in this little snippet. Of course, there's much more nuance and context beyond, the snippet context. And so tying you to the VOR is important.
Awesome. Does Scite connect to any reference management tool? Just thinking about the easiest way to save any useful citations or references.
Yes, it does. And so you can download any RIS or BibTeX file from pretty much every page you see. We do also have an integration directly with Zotero and Mendeley, so you can incorporate your stuff into Scite. We also have a Zotero plugin, although it's not very well maintained right now, but that will show you our numbers directly in Zotero. We're also integrated in many other tools, not just reference managers, but for large pharma, publication planning tools, some key opinion leader finding tools, some systematic review tools, et cetera. And so really, not trying to replace every single workflow, but to enhance a lot of different tools and workflows through partnerships and integrations.
Amazing. Okay, we're at the hour mark, and I do want to be respectful of all of your time. So let me end this with one comment and one last question. The last question is, any homework for us today? Any realists? I love this question. We'll be sending in that weekly email, which the next one will go out next week, which will include the recording. We'll have additional reading, really like on the foundational side. We'll have like a checklist. So that's, you can consider it homework. It's not real homework. It's voluntary, of course. But if you want to dive deeper, you can do that with that next email going out. And then also, I know we have quite a lot of questions that we didn't get into. Many of those questions that I saw, we will actually cover over the next 8 weeks. So as Josh mentioned, next week, deep dive into Scite. Then we'll have a back end, like technical session about Scite. We'll talk about AI in the classroom and AI in corporate research. So I hope after these 8 weeks, we'll be able to get clarity on most of your questions. If you have more of a technical question, I'm sending our customer support email address here. Feel free to reach out to them, and they'll be able to help you probably as quickly as possible. With that being said, thank you so much, Chris and Josh, for kicking this off on this first session of the bootcamp. This was amazing. Thank you so much, everyone, for signing up, for joining. Feel free to reach out anytime, and I'm really happy to see you in 2 weeks' time live again.
Thanks. Happy weekend.
Thanks, everyone.
Bye, everyone.
Bye.